The goal of a project is to build the right product and build it right. In this video, we'll focus on the first part, building the right product. That's where requirements elicitation comes into play. In this video, we'll cover the 5 most important aspects of the requirements elicitation process that you must consider in your project, along with the most common pitfalls to avoid. We'll discuss what this process is about, the differences between stakeholders' needs and expectations, stakeholder requirements, and design constraints, how to analyze stakeholder needs, and how to handle hundreds of documents effectively in projects. Keep watching, because by the end of this video you will have a deeper understanding of this process and know how to apply it effectively in your Automotive SPICE projects. I'm Giuseppe, I'm a principal assessor and instructor in Automotive SPICE. On my channel I share knowledge about software quality and software engineering. If you find my videos helpful, please consider subscribing to my channel. Your support helps me create high quality videos and keeps you up to date with the latest Automotive SPICE best practices. So let's start by clarifying what the SYS.1 Requirements Elicitation process is actually about. According to the Automotive SPICE model, this process includes activities such as collecting stakeholders' needs and expectations, analyzing and clarifying them to remove ambiguities and conflicts, converting them into stakeholder requirements which will lead the development. Now, let's make clear what is the difference between stakeholders' needs and expectations and stakeholder requirements. Stakeholders' needs and expectations are often expressed in natural language and can be generic, emotional, or high level. For example, the system should start the engine quickly and reliably. A stakeholder requirement, on the other hand, is a formalized and verifiable expression of that need, such as the engine control unit shall enable engine start within 500 milliseconds after key on at 12-volt battery voltage and ambient temperature. So elicitation is the process of transforming intentions and desires into clear, actionable requirements. In short, SYS.1 defines the set of requirements that the right product must fulfill. Getting SYS.1 right is essential because unclear or incomplete requirements at this stage can result into reworks, design issues, and poor quality later in the development. So the first critical aspect that a project faces is to identify all relevant stakeholders, both internal and external. According to ISO 25010 standard, a stakeholder is a person or organization that has an interest in a system and expects it to meet certain needs. In the context of engine control unit, for example, let's look at some of the typical stakeholders and what they care about. So we have the customer, the car maker. They care about compliance with performance targets, fuel efficiency, diagnostic capability, working environment of the ECU. Of course, we have the drivers, the end users. They look for smooth engine start, responsive throttle, low fuel consumption, and minimal vibration or noise. Then we have regulatory authorities. They care for compliance with emission standards, safety regulations, cybersecurity, and homologation requirements. Then we have production and manufacturing. They care for the ease of assembly, materials, robust connectors, or, for example, consistent software flashing process. Then we have service and maintenance. They care about remote update capability, standardized interfaces for service tools. Then we have platform and internal engineering teams. They care about software reuse, software architecture compatibility, defined interfaces with other control units, like for example transmission or body controller. Then we have marketing and product planning. They define features that create customer value. They care about differentiation from competitors and alignment with brand perception. Then of course we have quality. Quality requirements such as performance, safety, reliability or maintainability define how well the system must perform its functions. They are directly linked to the ISO 25010 quality model, which we discussed in a previous model. You can find the link in the description below. Each of these stakeholders brings a different perspective, and missing even one group can mean missing critical requirements. To summarize this session, remember to identify all internal and external stakeholders, including marketing and product planning, systematically document all stakeholders and their needs using structured methods and checklists, review and update the stakeholder list throughout the project as interfaces and expectations evolve. The next point is about collecting all stakeholders' needs and expectations. As we have seen in our previous videos about software quality based on ISO 25010, stakeholder needs and expectations can be stated, implied, and unaware. Stated needs are those needs that stakeholders can clearly express. For example, the diagnostic interface must support the USD protocol. These are explicit and easy to capture, but they often represent only a small part of the overall picture. Implied needs are not directly expressed, but they can be logically derived from the context, standards, or domain knowledge. For example, if a customer specifies that the ECU shall support over-the-air updates, it's implied that cybersecurity protection and rollback functionality will also be required. Unaware needs are requirements that stakeholders themselves may not consciously recognize, but that are essential for a proper operation or compliance. For example, a stakeholder might not mention thermal protection for an ECU that is mounted in an engine bay, but it's obviously required for reliability. Identifying implied and unaware needs requires experience, domain knowledge, and cross-functional collaboration. Now let's go to the methods that can be used to collect stakeholders' needs and expectations. First method is interviews. This is ideal when dealing with customers, regulatory experts, or domain specialists. Then we have workshops. These are structured sessions where multiple stakeholders participate to discuss requirements, align expectations, and resolve conflicts. Questionnaires and surveys are efficient when dealing with large user groups or distributed teams. They help capture qualitative feedbacks or rank priorities. Questionnaires and surveys are efficient when dealing with large user groups or distributed teams. They help capture quantitative feedback or set priorities. Simulation and prototype help stakeholders visualize functionalities and identifying missing or unrealistic requirements. These are excellent for uncovering implied or unaware needs. Then we have document reviews. Many requirements are already written down in contracts, standards, or corporate guidelines. Systematically reviewing and extracting relevant information is essential. Finally, we have benchmarking and market analysis. These are often driven by marketing or product planning to understand competitive features and customer expectations from the market. In practice, most organizations use a combination of these methods, starting with document analysis, followed by interviews and workshops, and validating assumptions through prototypes or simulations. Of course, every collected need or expectation must be linked to its source stakeholder. This is vital for traceability and accountability. It ensures that every requirement can be justified, clarified, and updated if stakeholder priorities change. Now, in large automotive projects, managing large number of inputs can become extremely demanding. Imagine dealing with tens or even hundreds of applicable documents, customer specifications, legal frameworks, corporate guidelines, and internal standards, all in different formats and revisions. Managing this manually is nearly impossible. Tools are essential, such as requirements management systems that support import, classification, and traceability, for example IBM Doors, Polarion, or Codebeamer. However, tools alone are not sufficient. That's why many organizations have specialized teams dedicated to handling specific categories of stakeholders' expectations. For example, regulatory requirements teams who understand safety, emissions, or cybersecurity rules and distribute the relevant requirements to affected projects. customer-specific requirement teams who analyze customer specifications and clarify expectations with customer engineering, quality and compliance teams who monitor adherence to corporate standards and certification requirements. These teams are knowledge filters between the external environment and projects. They ensure that every project receives the relevant requirements already clarified, instead of being overwhelmed by hundreds of documents. So collecting stakeholders' needs and expectations is a structured process that requires understanding different types of needs, stated, implied and unaware, applying a variety of elicitation techniques, maintaining traceability to the sources, and organizing your company to manage information efficiently. Doing this well sets the foundation for accurate, complete, and traceable stakeholder requirements, which are the cornerstone of a successful SYS.1 process. The next important aspect is about managing design constraints. In real life, stakeholders don't just express their needs and expectations, they often also provide design constraints to their suppliers. To manage this properly, it's important to understand the difference between stakeholder requirements and design constraints. Requirements answer the question, what must the system do to fulfill stakeholder needs? Requirements are the formalized, verifiable translation of those needs and expectations. They describe what the system must do or how it must behave, in a way that can be checked through design, implementation, or testing. Design constraints are limitations or boundaries that restrict how the system can be implemented or designed. They do not describe functionality. Instead, they define conditions that the system must respect. Design constraints can come from many sources: customer contracts, regulatory requirements, internal standards, or physical limitations. For example, this SKU shall use the existing 32-bit microcontroller from a given supplier. The software must be written in compliance with MISRA. The total power consumption of this SKU shall not exceed 8 watts. The housing of this SKU must fit with a given mounting position. These constraints limit design freedom but ensure consistency, reusability, compliance, and feasibility across projects. For these reasons, many car makers provide design constraints to their suppliers. Design constraints, when identified, must not be taken for granted. They should be questioned, analyzed, and discussed. Behind design constraints, there may be conflicts with other stakeholders' needs and expectations, and these must be carefully evaluated. No hidden requirements behind design constraints should be available. So many organizations struggle because these concepts are mixed together in specifications. This confusion impacts on test coverage and makes it difficult to verify compliance or manage change effectively. In Automotive SPICE assessment, we look closely at whether requirements and design constraints are clearly separated and traceable, because this separation is fundamental to process maturity and product quality. This also increases project efficiency, because design constraints can be linked directly to software or hardware requirements or architecture, provided that an analysis is performed at system level. In summary, be aware of the difference between design constraints and requirements and identify, analyze, and trace all design constraints. The next point is the right way to translate stakeholders' needs and expectations into stakeholder requirements. This step is about reaching a shared and documented agreement with all stakeholders on what the system must deliver, ensuring that their needs and expectations are clearly understood, consistent, and realistic. It creates an approved baseline of stakeholder requirements that becomes the official reference for all subsequent engineering activities. So these are some of the steps that are required in practice. Define roles and responsibilities for requirements ownership and approval. Avoid everyone and no one situations. Use requirement attributes to classify, manage, and communicate requirements effectively. Typical attributes are priority, source, status, type of requirements like functional, safety, quality, etc. Capture and maintain conflicts between stakeholders' expectations, for example, cost versus performance versus maintainability, and design constraints. Quantify unmeasurable requirements with measurable attributes. Review stakeholders' needs and expectations for completeness and consistency before converting them into requirements. In the reviews, involve cross-functional stakeholders like quality, manufacturing, service, cybersecurity, marketing, etc. Check alignment with higher-level standards and regulation like ISO 26262. Define acceptance criteria for each requirement, how stakeholders will judge whether it's fulfilled. Validate requirements early with prototypes, mock-ups or simulations to uncover hidden expectations. Use version-controlled requirement baselines to ensure all parties agreed on the same scope at each release phase. And finally, agree on change management rules, how stakeholder requirements can be added, modified or removed. Reaching full agreement on stakeholder requirements demands significant effort, as it involves coordination across multiple disciplines, performing reviews, and resolving conflicts. Failing to document all requirements introduces technical debt. This is the accumulation of shortcuts, gaps, or compromises that are made during development that save time in the short term but create extra work, rework, or risks later on. Each of these ambiguities becomes a form of hidden debt that must eventually be paid back through redesigns, change requests, or bug fixes, often at a much higher cost and under greater pressure. That's a summary on SYS.1 Requirements Elicitation. Jump now to my video about Validation 1, the new validation process in Automotive SPICE 4.0, to learn how to make sure the system you are building truly fulfills all stakeholder requirements and finally all stakeholders' expectations and needs. Thanks for watching and arrivederci.